Share my presentation. Hello, everyone. Um, so, Carmelo, I cannot share my screen. Could you
One
allow it
second.
so I can share the presentation?
Try now.
Yeah, there it is. All right, so let me choose my presentation. All right. Should be displaying in just 1 second. All right, is my presentation being shared on the screen?
Yes, Christian.
Okay.
You can also put in the presentation mode.
All right. Thank you. So, hello everyone. Good afternoon for you. Good morning here. And in today's talk, I want to talk about my title doesn't show here, but it's about what is artificial intelligence, machine learning, and deep learning. And those are really broad topics. Today, I'm going to try to just go through the overview of those technologies. And I will also show you some of the applications that we have been working on over here in the group that I'm working on, the school. And hopefully by the end of the talk, you will have a much better idea of the whole artificial intelligence, machine learning, and deep learning general concepts. So let me start with the following. And this is just something quite simple. And if I know for sure that if I ask anyone about this question, is this a dog in the images that I'm showing here, everybody will agree that those are indeed dogs. And this is something that we humans do quite easily because we have, adaptive brains to recognize animals, in our environment, and any other object for that matter. But let's focus on the dog example for now. So we as humans, we do recognize this quite easily. But what about if we want a machine do the recognition for us? It's not the same to, let's say, create a program that a machine understands that can be used to identify dogs from images. So in this regard, artificial intelligence, it's trying to somehow make a computer understand different type of data, in this case images, in a similar way that a human does. So that's the basic idea behind artificial intelligence. So let me just explain this graphic really fast. This is the hype cycle. It's provided from Gartner, and it basically depicts the following. So if we think about the technologies that are pushing forward artificial intelligence, we have a broad array of technologies and new concepts being shown in recent years. And it's right now we are living in the trigger area, in the innovation area. The hype is intense. And if you go to the internet, you will see a lot of information about artificial intelligence and applications of machine learning and deep learning. And everybody's talking about it. Everybody is saying that they want to do it or they are doing some of this, especially in big companies. And there are many startups showing up, developing new technologies that push forward all of this general area. And that's great, but this graphic over here depicts the general idea of any technology that once it appears, it creates this sort of inflated expectations about the possibilities of the technology. And then at some point it reaches the peak of the expectation, and then finally people start to realize that there are some limitations to the technologies that will basically bring down that expectation. And then once we reach a bottom, the technology starts to mature enough so that we can really harness the true potential of the technology until we reach a stability point, a stationary state. And so this is where we want to be at some point after pushing the technology forward. And this is exactly where we, as community, society, can harness the true potential of those technologies. So just to name a few, we have cloud technology, GAN networks, transfer learning, synthetic data, edge artificial intelligence. And I will talk to you about some of the applications in one of them, some of them, but it's too broad and there are too many examples. So it's good to know some of them. And artificial intelligence is actually shaping our current society. It's been deployed in many applications, in many areas, and I will explain to you in the next slides some of the small things that you probably are doing right now, where in fact it's being used some sort of machine learning or deep learning techniques and methodologies to give you that functionality in devices and systems. All right, so let me continue describing the general idea of how artificial intelligence, machine learning, and deep learning relate to each other. So at the other space, we can define artificial intelligence just briefly as computer systems that perform tasks that normally require human intelligence. And by this, what I mean by this is basically imagine a human. What we do is to reason. We discover meaning out of data, out of something else that we had contact with. We can generalize the concepts and translate the knowledge to different areas. We can learn from past experiences. We can solve problems, and all of these areas of expertise is what we really master and are good at as humans, right? And define us as being intelligent beings. But in terms of a computer is we are trying to program computers to do similar things, similar to a human. So the romantic idea of those robots that behave like humans, that think like a human, and even have feelings is, that romantic idea is the general artificial intelligence concept. We are not there yet. It's too far away. But that's the general idea of the goal of this whole technology. And so back to reality, we are using computational methods to learn information directly from data. And that is a very short definition for what machine learning is. We are trying to teach computers how to perform some of these specific functions that a human does, starting from the data. And another subdivision of all of this is deep learning. So deep learning is a very specific, let's say, methodology, and there's specific techniques there that uses a basic concept, which is an artificial neural network. And by doing so, what it does is it learns from the data, but it actually keeps on learning as we feed more data to the computer. And in some examples that are probably quite famous right now is the fact that computers are now getting better results and beating humans in activities that are normally recognized as being activities that we as humans do well because we are intelligent. And now computers are competing with us. And examples of that could be, for example, chess games. So if you play chess and you are good at it, now computers are being much better than humans are. Google, for example, made this competition, and the artificial intelligence that they were developing beat another player that was the best in another area, in another game, which is Go. And those type of developments are being developed by using deep learning methodology. So this is current technology, and it's shaping the future as we speak, and it has a bright future ahead. So let me describe a little bit more about machine learning and how we do it. So let's continue with the example of the dog. And let's say that I want to train a computer to recognize dogs from images. So what I need to do is get a collection of these pictures. And by the way, I need many of those images, in the thousands or tens of thousands or more images, just to start to train a computer to recognize the images. Now, the next thing to do is I'm going to split this data set into different portions, and then I'll start to train the computer model to recognize the dogs in the images, and then I will validate that information with another portion of the data. And once I am satisfied with the results, once the computer can detect that, in fact, the animal being depicted in the picture is actually a dog, then I will use that model that I obtained after training with the data. And then what I want to do is I want to test that model to test if the model is working properly. So now what I will do is, if I wanna use the model, what I will do is simply take new pictures from more dogs, pictures that haven't been used before to train the model, and then I will ask the computer tell me if the new image is indeed, in fact, from a dog. And so what it will do is it will tell me, well, yeah, the image does belong to a dog. A dog is shown in the image, or no, there is no dog in the image. So that is the whole idea of machine learning. We will learn from experience by sending more images to it, and we will use computer methods to learn the features that are important to recognize dogs. So now let's go a little bit deeper, and let's say that I want to do something similar, but now instead of using machine learning, I want to use methodologies particular to deep learning. And I mentioned before that the basic construct of deep learning is actually something called neural network. And this is the general way to depict a neural network. And what it is the following. Imagine that a neural network is doing something, it's having some resemblance to a human brain. And these dots over here, the circles, behave like neurons, similar to what a neuron does in the human brain. So a neuron connects with other neurons, and in doing so, you continue through this whole structure until you have an output of the sequence, right? And the idea of these connections is that once we bring in new data, the data is going to be decomposed into final elements, and the connections in here are actually different weights. Let's call it coefficients that gets updated every time a new image comes in. And so the whole process is iterative in a way that once you bring a new image, it will learn features about the image, and it will update all those weights, all those coefficients in the network, so that in the end, it can discriminate between objects in the image. So if you want to find dogs in the images, then this neural network has to update itself automatically in a way that best fits the data coming in from the images, data where dogs are presented. And you can do the same for non-images. So for example, maybe you have text files and you can analyze those too. Maybe you have electrical signals or sounds, and then you can do the same, pass that information through the neural network and obtain an output. Now, another thing about this is that this has the potential to have a really high accuracy. And we do care a lot about accuracy, because the higher the accuracy that we can get from these models, the better it will perform doing the task that it has been trained to do. So if we obtain a high accuracy to detect ducks in images, then anytime that we bring a new duck image, then it will for sure tell you that there is in fact a duck in the image. And the last thing to mention about deep learning is that these structures, we have no influence on what is being learned. So what I mean by this is that we as programmers, we as humans, we as engineers, we don't have a way to influence the weights that are being updated here once new images comes in, because this is an automatic process. And this is one of the, let's say, conundrums of using neural networks, because as engineers, it's a little bit difficult to explain what the neural network is doing in minute detail. So it's difficult to explain why one connection is having a value, a certain value that it now possesses. So that's the difficult thing, but the end result is there. The end result will give you in this case, the classification that you are expecting for. So the layers in here are called hidden layers, and just because they're in the middle, then you have the input layers at the beginning and the output layer at the end. All right, so this is how normally you will look. You will have the graphic for trainings of any model. So if you want to do classification. So over here, for example, you have an accuracy graphic where, as you can see, the accuracy is getting higher and higher until it reaches a plateau as you iterate more and more on the data you have. This is the normal expected graphic that you should obtain when you train any of these models. And on the other hand, on the bottom, you have the loss curve, which is basically the same as saying what is the error of the model as you train it. So as the accuracy gets better, you expect the loss plot to be lower and lower, because you are having a much better model that models the data that you are sending into the network. One note about this is that whenever you do any of these jobs of training a model to create classification or other type of machine learning, you actually need to do it with hardware that gives you an edge. So for example, these are really computationally intensive tasks. So you need strong hardware in order to do it faster. In an example that I have over here, I'm using, for this particular training, I'm using multiple GPUs. So this is a PC computer that has 2 graphics cards, and I will talk more about this in a moment, but it has multiple graphics cards because this is so computationally intensive that if you do it only with a processor in the computer, it will take much more time to complete a task. Right, so that's something to keep in mind. And just talking about the overall machine learning techniques and the distribution of those techniques is as follows. So if you go to machine learning, you're gonna find mostly 2 broad categories, which is supervised learning or unsupervised learning. In supervised learning, you have 2 different categories. One is classification, and this is actually the same that I have been describing so far. The duck image coming into the network and then obtaining an output that classifies if the image has indeed a duck in the image. That is a discrete response, and that is a classification task. But you can also do some regression. This is like the regression analysis you probably see in your college classes. And this is all about continuous responses. So you have a variable that has a continuous response, and you can create models that actually perform regression tasks on those variables. Think about temperature, for example. Maybe you want to get the temperature which is continuous, and then you can create a regression analysis to obtain that answer. And if you go to the unsupervised category, you have clustering methods, which in fact are used, for example, when you want to explore the data in a huge data set. Maybe you don't know exactly what's happening with the information that you have. This is common in consultancy. Maybe a company tells you, you know what, we have this problem and we have this amount of data, but we don't know what's happening and we don't know the relationships that are the strong relationships between the data that is driving to the results. So please help us find what's happening. So clustering techniques in unsupervised learning, actually, they are being used a lot for those type of situations where you want to explore the data and just find the relationships between the data. So now, let me talk about the technology drivers that are actually important for the, the whole picture of how artificial intelligence is being deployed nowadays. So as technology drivers, we can say that we have massive amount of data. So data has been going up. I mean, the human as a civilization, the human civilization is creating more data per year in recent years than in the whole history of the human activity. And this is quite interesting because in the last few years, we actually have most of the data in like few years. This is very important because in machine learning and deep learning techniques, you need massive data sets to train those models. Otherwise, they won't be good. So this is something very important for this technology. And think about, there is something called ImageNet, which is one of the oldest big databases for images that was used to create the first models for image recognition and classification. You also have a lot of electrical signals being recorded. So companies are actually getting a lot of data, so they can deploy sensors, and those sensors record variables, in the fabrication process, and those variables are being recorded and stored in massive data sets, right? So think about the influence of IoT, which is also something new, and this is also growing, and as it grows, it will generate more and more of these signals and these recordings, and it will be available to us to use that data and train these models to do some tasks. Also cloud technologies, you can do all of this either locally or on the cloud, so this is also a huge deal for this technology as a technology driver. And then you have something else. You have the increase in computing power that we are now experiencing by major companies. So think about the processors that we now have. We are using fabrication techniques that are much better and efficient than before. And the current power from processors is actually leaping forward quickly as we speak. So this is very important too. Also, the specialized hardware, such as graphic computers, are getting better and better every time. So those are important factors that drive up the technology of machine learning and deep learning. And also, it's important to mention that there is a lot of community that's helping develop these methodologies, and it's providing pre-trained models that do something really well. So let's say that maybe a group of researchers create a new classification model, and then what they do is normally they provide this model to the community so everybody can use it. And it's been deployed in many areas. So this is also a technology driver that is driving up how we use and how machine learning and deep learning is shaping the future of the world and the technology. Also, it's worth to mention some of the major players from companies that are pushing forward this technology. And we have the likes of IBM, Google, Microsoft, Apple, NVIDIA, and so on. All of them are very important players. They are investing a lot because they are buying small companies, startups that are very good at something of machine learning or deep learning, and they buy them and use that technology and simply put, gets their services or hardware even better by doing so. And in general, we as clients and users of the technology benefit from those improvements too. So those are major players. Of course, there are many more, but these are the ones that are more predominant because of how much they spend on research about machine learning and deep learning. So I want to talk about some of the applications of machine learning and deep learning. And you have the classical virtual personal assistant applications. You can do some video analytics where a computer automatically analyzes video, for example, security videos. You have gesture control. Maybe you create an application where you detect the movement of your hand on the screen, and then by doing so, you can predict what the user wants to do. And this is quite interesting because now we can design technology that actually responds to human contact. You also have speech-to-speech translation. So the boundaries of different languages are being erased as we speak. We have computer vision, which is everything related to how a computer detects, analyzes, and classifies images. And you have natural language processing, which is quite interesting because imagine that computers are now listening to us and interpreting what we want. Think about maybe a Siri or the Google Assistant, where you talk to the cell phone and then they interpret what you're saying and they give you results because of that. You also have smart robots doing interesting things in industry and in consumer service. And you have recommendation engines. For example, think about Netflix, that Netflix knows a lot about what we like, and then we are being fed with new series or movies that are similar to the movies and series that we watch and we like. So those are recommendation engines. There are many more applications. These are just some of the main applications that I can talk about. And let me mention something else that's also driving a lot of the improvements that we are experiencing currently. And this is new frameworks such as ONNX. ONNX stands for Open Neural Network Exchange, and it's an effort from different major companies that their objective is to erase the limitations of hardware and software for someone to apply machine learning and deep learning methodologies. Because most of the times, you probably start learning one language or using one framework, and then maybe there is a different group or different development going from a different area. And in earlier days, we were limited because if we didn't know how to code, how to use those different libraries or those different frameworks, then we were limited because of that difference. But now that difference is being erased because we can actually jump from each one easily. So if someone is programming in TensorFlow and someone else is using, let's say, Caffe or PyTorch or Keras, now we can communicate between the different frameworks, import and export what someone else is doing in another framework and use it. So that is powerful, and this is something quite recent, and it's great. So I recommend you to, if you are interested, go check it out. It's quite useful. And also the deployment targets that we can access with this compatibility now with ONNX is actually great because we can think of deploying things locally in computers. We can think of deploying things in robotic arms. We can think in deploying things on the cell phone or on the cloud, or using GPUs or specialized hardware like neural processing units. So it's exciting in the time we are living because now we have freedom of choice in frameworks and freedom of choice in the deployment target. This is just part of the frameworks. I'm just gonna leave this image over here. The major frameworks are depicted here, but there are many more. So those are also compatible with ONCs. I recommend you to check it out if you have the time. And what I want to do now is I wanna show you some of the examples and projects that we have been developing where I work. With students and from my own. And I want to show you 4 different examples. One is about speech recognition. The other one is something else we did for detecting the machine usage during the training of people for that machine. Then I'm going to jump into person detection for risk identification, and I will explain about this in a moment. And lastly, I will show you one of the projects that we developed recently because of the whole pandemic, the COVID-19 pandemic. And it's about how we are using X-ray images to try to detect COVID-19 cases from those X-ray images. So now let's start talking about speech recognition. And what we wanted to do is just to demonstrate how to do some speech recognition. And what we did is we took a data set from American English native speakers, and it has many samples from different people saying different words such as down, go, left, no, off, and so on. And what we did is train a computer model to detect those sounds from those words and simply tell us if the new sound coming in was exactly indeed one of those words. And if it was not, well, it will tell you nothing, or it will tell you that it's from an unknown category, maybe because it's a different word that's not none of this. And so we trained the model. It took some time, maybe about an hour. I'm using a simple computer, use single CPU to train this. And as you can see, it reached an accuracy of around 84%. So that's good enough for the recognition activity. The loss is actually in a good place also. So now what I want to do is I want to talk about the confusion matrix, which is something that we use as a tool to determine if the training is good or not beyond the plot. So what it's saying over here is that maybe over here we are talking about yes category of words. So if we hear a yes and the model detects a yes, then we say, it's working properly. And the same goes for the other words. This diagonal over here, the main diagonal of the matrix, actually tells you how good it is to detect that particular word. And as you can see, those are actually good results. I mean, most of the times the model detects the word properly, and sometimes it doesn't, but most of the times it does. So we say that, okay, it's good enough. Let's try it. Let's test it with new sounds. And I wanna place 2 samples that I recorded. And one of them is actually my voice. And what I want you to see is that pay attention to the sound. And then over here at the top, you're gonna see a label. And that label is gonna tell you what the model is recognizing from the sound being spoken into the mic of this particular example. So let's hear it. Yes. Up. Up. No. Down. Left. Right. On. Off. Yes. All right, so that was the first example. As you can see, most of the times it detects the word and it tells you the label about what the model thinks that the word is. And it's actually my voice being here in this example. So I am not an English native speaker, so maybe some of the difference are because of that, but it's good enough. I think most of the times it got it right. So now let me show you, let me play a different example. This is from a female voice. My partner in life actually helped me record this, and let's see how it performs on this example.
Yes. No. Up. Down. Left. Right. On. Off. Stop. Go. Shake.
Okay, that was the words that we trained to recognize, and now she's going to say words that we didn't train to recognize. So in this case, the model, what it does, if it's a word that we didn't train to recognize, it would say unknown because it doesn't know what it is.
Baila. Six.
So as you saw, a couple words, Sheila and six, even though those are words that could be recognized because those are English words or names, the model does not recognize those, and it says unknown because it was not trained to recognize those words. And I actually think that the second sample is actually better at speaking English than the first one. So yes. Anyway, oh, let me stop this and continue. All right, so that was the first example, and I hope you like it. Now, I'm going to talk about the signal classification for machine usage. And the whole idea of this is that we wanted to, let's say, detect how a machine was being used in the process of people being trained on that machine. And what we did was we recorded signals using accelerometers that are being, stick to the machine. And then by recording those signals, we classified those signals by the activity that we were performing during the training. And I'm sorry for the labels, this is in Spanish, but what it means is that each one of these colors in the signal represent a different activity during the process of using the machine. And this is a typical good way to use the machine. And what we did is we trained the model to recognize good typical ways, good typical signals to actually use the machine, right? And well, we obtained something good enough to start testing the model and get some results. So now, let me go back just briefly. So by the way, this process is iterative. It's not just one signal. Remember, we need a lot of data. So we did a lot of different tests. We recorded many signals and we fed the computer model with all that data. And this process goes on and on again until we obtain something good enough. And of course, as I mentioned before, we can use specialized hardware. We can use cloud computing or other hardware such as graphic processor units or tensor processor units to train these models. Now, for the next portion of the test, we wanted to test new signals that now we are sending into the model that we trained first, and we wanted to determine what was happening with those new signals. So what you see here, over here in this area, is actually the test data. And the test data, it's just about an accelerometer with X, Y, and Z recordings. And those signals were being sent into the computer model. And the computer model will tell us what's happening according to those signals. So remember that these are just different states of the machine when we use it. And maybe you can see it here. There are two lines overlap, and there is a blue one and a reddish one over here. So the red one or orange one is the test data. So this is the data that we are sending into the computer model. And the blue one is the predicted outcome, the predicted classification for the activities being performed from the people, right? So as you can see over here, both the data and the predicted is actually in a good position. They overlap each other. So it means that the model is actually predicting the right classification for the activity according to the signals that we are sending in. And this is great because this is telling us that the model is good enough to recognize the activities being performed while we use the machine, right? So imagine this. If I want to train new users to use a machine, then for sure I can use something like this and measure the accelerometers in that machine to determine what is going on with the machine. And this is something that can be applied in many different areas. Sorry. You can also do this with specialized hardware or on the cloud, so just to keep that in mind. So I'm going to go a little bit faster here because I think I'm running out of time. So let me talk quickly about the person detection for risk identification project. And this is quite simple. We wanted to somehow devise something that will use cameras to determine if a user, let's say in a company or a fabric, an industry, is actually in a place where it's dangerous or not. And all companies have different measures for this, but the idea is that you could face potential dangers if you go into an area that is dangerous and you don't have enough care. And sometimes you have cells that protect dangerous equipment and people cannot go inside, but sometimes they need to go inside to perform, you know, another process. And there are certain controls to keep that safe. But sometimes the controls do not work or people bypass the controls. And this is the whole idea of this. So if the area is safe and everything is good, then the system will say, you know what, you can be inside, it's okay. But if it's not, then the system should send alarms and say, you know what, something on is going on here. This is dangerous for the people. This is dangerous for the user. Please send someone or stop that activity. And so let me play a small video. And what you will see here is the following. So this area, imagine that the red area is actually a portion of the floor plan that a user shouldn't be there. For example, and the camera is trying to detect when a person goes into the area that is unsafe. So Gil Flores is a student that was actually performing this project. And let me show you the video and explain what's happening over here. So right now, what happens is that the computer model is detecting a person, in this case, Gil. And once he goes into the area, it detects that there is a human person, a body into the area, and it changes colors. So once he steps out, it goes to green, and once he steps in, it goes to red. So that's basically what the model is doing. And it's very robust, actually, because as you will see in a moment, Gil gets hidden behind a chair partially. And the model is still good enough to detect that a person is still there. So look at that. So have a person, maybe, you know, he's hiding a little bit, and the model is actually quite robust. It detects the person that has been there, hidden. If you go and turn around and maybe you are not facing the camera, that's fine. The model detects the person. And we were thinking in using this, thank you, Gil. We were using this model to actually send signals, alarms, when a person was into an area that shouldn't be in there. So that was the whole point of this activity. Oops, sorry. Now, let me move on to the last example that I have for you today. And this is something we did. Actually, I was doing this project during the portions where from Mexico, where Mexico was actually starting to ramp up in the number of COVID-19 cases that were detected. And we were trying to do something to deploy, at least academically, to detect classification of X-ray images for COVID-19. And by now, I mean, you probably have seen this type of images before many, many times. I'm just playing this in here to stress the fact that it's a pandemic, is worldwide, and the health systems from virtually every country were not prepared to handle something like this. So we are facing a lot of supply shortages, and we don't have enough medical doctors or hospital facilities to attend all of them, to take care of all the patients that were coming in. And many countries, Italy and the US in certain cities and many different areas, were having a really bad time with this. Spain was actually there too. So we need as researchers, engineers, technology developers, we need to come up with clever solutions in how to provide some help to try to decrease the problems that this pandemic is creating. And what we did in this project was actually something like that. Remember, this is just an academic project. We are still not doing this for deployment in hospitals. But the idea is that we started with a collection of images from X-ray images. And the reason why X-ray and not something else like CT scan, which has far more resolution, is because in certain countries, such as Mexico, for example, an X-ray machine is actually much more available in hospitals and different areas than a CT scan machine. And this is also cheaper to obtain. So from an economical point of view and a resource point of view, it's much better to work with X-ray images. And we started with a huge data set from normal images. And we say normal images, what I mean by that is that the people that was getting these X-ray images, X-ray radiographies, are healthy. So that's a normal image. And on the other hand, we have people that are actually sick of something relating the lungs, maybe pneumonia, maybe a viral pneumonia or bacterial pneumonia of some sort, but it's not COVID. So this is no COVID situation, but not normal. And on the last portion over here, the red one, we are saying, okay, so this is the COVID-19 cases that we know for sure that are detected, and these are the X-ray images from those cases. Now, one thing to mention is that we have a lot of this because it's available freely on databases. We have a lot of this. Those are available too from different competitions and different databases that put this openly for the public and the research community. But we don't have many of these. So we have very little of the COVID-19 images. So this is one of the situations where we struggle a lot to obtain images for COVID-19. Nonetheless, we did obtain some, and we started using them to train the models. So what we did then is we are applying some deep learning methodologies to this model. And then we're also applying some classification layers, which is nothing else than a layer that classifies the images after it has been trained on a first deep learning layer. Now, once we train the classifier, then we validate the classifier, and if it's good enough, then we make predictions with that classifier. And the prediction is basically saying, is the image that you are presenting to the computer model an image from COVID-19, or it is not? So that's everything. It's output from the computer model, and some new images that may come into the model will go out as it's COVID-19 or no, it's not COVID-19. That's all it does. And this is how the application looks like. So the application we coded is looks like this. Of course, this is the university that I'm working on, Tecnológico de Monterrey. And everything you have to do, as a user from the application is click this button, which it says diagnose. So it will let you go to a folder where you have your X-ray images that you want to analyze, and then it looks like this. So once you click on the image and bring the images, then those images are being analyzed by the computer model, the application, and then it will throw you an output saying, where there are some cases of COVID-19, please pay attention to those cases. It will let you know which one of the images the computer model determines that those are typical COVID-19 cases. And this is very helpful because, as I mentioned before, the medical doctors and the hospital, the health systems in general are overwhelmed with the amount of cases in some areas, in some cities. So having a tool like this may be helpful if you can think of a situation where, I have all of these resources, but I don't have the doctors to analyze the images. I'm lagging behind. I need something that help me do it faster. Maybe this type of systems can help determine a big amount of data that's available, but is not being processed because of lack of personnel or because you don't have the means to do it. And I think, this is a very nice project. Again, it's not deployed in hospitals. It's not being used and validated yet by medical doctors. We are working with them in a project to validate this whole methodology and this application. But it's a good way to think in innovative avenues for we to try to use our technology, machine learning and deep learning algorithms to do something for the greater benefit. And I think that's it for today, guys. And I hope you liked the presentation. Thank you very much for paying attention. And if you have any questions, please let me know.
Christian, thank you very much for your presentation. I cannot see you anymore.
Should I stop the share maybe?
Probably.
Okay, let me stop my sharing.
I was wondering if there are questions by the audience. So,
Hello,
yes.
good afternoon. Mr. Christian, I have a question. So after going through your presentation and after you've actually done everything, I really appreciate it. But what I want to ask is that if you want to actually build a system that uses AI, will you actually prefer using MATLAB or coding with primitive data, like the primitive data analysis language like C?
All right, if I am comparing, thank you for the question, Aziz. If I am working with machine learning algorithms, I would prefer to use a language that actually has libraries that help us to arrive to a solution much faster. In the case of Z, I haven't used it for machine learning, but I think there are many more frameworks that are available right now, like the ones I showed you in some of the slides before, that you can use functions that are already coded that help you arrive to an application much faster than if you code in a very basic level, like for example, using C. I think we will be better using any of the frameworks for that matter.
All right, thank you, sir.
You're welcome.
So, are there any other questions?
Hello, sir. Good afternoon, sir.
Good afternoon.
Yeah, Victor from Nigeria. Please, sir, I want to ask, have you worked on some complex projects involving brain-computer interface? If yes, what softwares did you use for training those neurons and collecting data from the human brain, sir?
Could you repeat the area because I couldn't pick it up properly?
Okay, sir. Can you hear me now clearly, sir? Okay, sir. So I'm asking, have you worked on some projects involving brain-computer interface? If yes, then what softwares did you use? How were you able to collect data from, as a result of impulses going on in the human's brain? How were we able to get them and convert them to digital signals, sir?
I haven't really worked on that particular problem yet. So, but I'm sure that if you send me more information about the idea, I can help you find maybe how to do it properly, and I'll send you an email back to you.
Okay, sir. Thank you very much, sir.
Hi, can I ask a question? Mr. Mendoza, thank you. Hi, my name's Paul from South Africa, and I just wanted to ask, creating the systems that you did with X-rays used to try and detect COVID-19 or like illnesses, was very costly, like relative costs in terms of labor. Like, how exactly was that process for you, like your team, from a cost perspective?
Yeah, could you repeat the question because it was breaking up here?
Is it still breaking?
No, it's okay now.
Oh, okay. I was just going to ask, in terms of using X-rays to try and detect diseases and pathogens within the human body, was it very costly developing the systems that you were using, like as a team? Like, how was it from a cost perspective?
Yeah, we didn't pay much attention about the cost. Honestly, this application, I developed it myself, mostly in collaboration with another professor here. And we spent about, to be honest, 1 full week doing this. So we have something called, a Holy Week here, which is a vacation time. And we were at home and we were wondering what to do and how to do it to help with the whole pandemic situation. And we decided to apply for this application project. And we spent the whole week, 2 professors doing this. So in terms of cost, we didn't pay much attention. If we want to put some time to it, well, it's whatever professor will get paid for a week to do a project. But if you want to do something like this in industry, of course, you need to think about different things. For example, the engineers that are going to work on this, you probably need between 2 and 3 engineers that are focused only on this. You need computer hardware, specialized hardware to do it. For example, I do have PC computers here at home that I use for these projects. Those are powerful machines, but it's an investment of sorts. You need powerful graphics cards, especially for this. And you also need a lot of data. So maybe you need some drives to store that data, Or if you go to the cloud and do the training on the cloud, then you need to spend for the time of the training on the cloud, and that is, a variable cost. I don't have specific numbers again because this was not a paid project, but it's something worth to consider, and it's not too expensive to do it, especially if you use developments from different teams and adapt those teams and those developments to your own project. I think that will reduce the cost.
Thank you.
You're welcome. Yeah, this is still an academic project, so we haven't really put a price tag to the project. Maybe that will be something good, right, Carmelo? Maybe an innovation development that we can deploy and maybe sell. But we were not doing this for commercial purposes. We wanted to do the COVID-19 application to deploy it freely because of the pandemic. We were not looking into economic benefits.
Mark?
Yes. Yes, good afternoon.
Good afternoon.
Yeah, this is Mark from Sierra Leone. Of course, I am an entrepreneur, and I'm so curious about how can we as young people across the continent use artificial AI to solve some of the biggest problems we have in here. So let's say, for instance, I was thinking that we can actually use AI and AI-driven technologies to actually be able to dictate corona patient, and maybe like one can stand at the door, and when somebody passes by with this AI-driven devices, you can actually be able to dictate this person is infected, this person, this is the level of temperature, whatever the things are. So I was wondering if those
Mark?
Hello, Mr. Mark.
discussions are actually possible for tools and systems that we can develop within. And
I apologize, but probably, I don't know if, but for sure, I lost your question because your voice was interrupted. Can you repeat?
Hello, Mr. Mark.
Yeah, same here. Mr. Mac, your microphone should off when you were.
yes, yes. So I was talking about what would be possible to actually use AI-driven technologies to solve some of the problems we have, and even with Corona. How can we use locally sourced materials? I know it might be a big challenge, but honestly, I believe in creativity and innovation. It's possible. We can actually source some of this material within our continent or within our neighborhood and bring these things to life and help save our people. So is it possible that these things can actually work locally, that we can actually source materials and software-driven things and build them?
Yes, thank you very much for the question. I do believe so, because as I explained it during the talk, you can develop this type of applications, this type of artificial intelligence models using any computer. So, for example, some of the examples that I show you here, I did it on a 2-core computer, which is available in many areas, many places, and everybody may have something like this. And the only trade-off that you will have is that in order to obtain a model from here, you will spend more time. That's the only variable that's different. You can do it with any computer. You will only have to spend more time. Regarding the sensors, maybe if you wanna, let's say, this is very interesting. You mentioned something quite important, because if I want to do a new application, maybe I want to bring in new information from sensors, from the patient. Maybe I want to measure temperature. Maybe I want to measure something else. And I can create an application to get those recordings and then train the model to recognize something is going on with that patient. That is completely correct. And it's actually a great idea. You can try it with different sensors on the body, wearable systems maybe. and you can, as long as you can get the signals from those sensors being deployed, on the body, then you can use that information to train new machine learning algorithms or deep learning algorithms to do something, yeah, right? To get you, to tell you if that person is behaving in a different way, maybe is presenting symptoms that will lead to, a conclusion. And that's completely feasible to do. I haven't seen it, but it's feasible. You can think of situations such as, the smart watches that, some are some available, and some of the smart watches are detecting the heartbeat, or maybe the pressure or something else that is being used to detect something else. So the same concept applies.
Okay, thank you very much.
Welcome.
Christian, I have a question regarding the data that you need to validate the network, the labeled data. So the X-ray scan for COVID-19 were evaluated by expert clinician to be sure that they actually were correct. So is there any way to avoid this this evaluation by human expert, or we are still, so we need always this preliminary evaluation by human expert?
Yeah, that's a very good question, Carmelo, actually. Thank you very much. So let me try to answer that. I think we strongly need to still have the human in the loop. We cannot get rid of the expert advice from medical doctors in this type of applications. So we as engineers, we do need to work together with medical doctors in order to get it right, because we are not the experts in medicine. We are the experts in technology. And actually, most of the traditional methods, and the methods that are being trained for machine learning and deep learning use classified labels. So labels that we know is true, that belongs to a certain category. And of course, the models that you train will be biased with the input that you send in. If the input is wrongly labeled, then your model may say, you know what, this is great model, but then when you try to use it on the outside, for new cases, it will not be so good because the label data was not good. So we are still bound because of that. There are some projects and improvements alongside that idea, where imagine this, a computer is now generating new images that look like something else similar. And in this regard, you won't need a human anymore, because the computer will actually generate those images. And this is something super interesting regarding GAN networks, generative adversarial networks. But coming back to your question, we still need to have human in the loop to get it right. I mean, and this is my opinion. And actually, this project, I didn't mention that because it's something more administrative, but we want to perform this project in collaboration with medical doctors, right? So we are still sending a proposal to the government to look for grants, and we are actually taking into account the money we need to spend hiring medical doctors, radiologists, to determine the right classification for the X-ray images. So that's something that we are taking into account for this type of projects. So it's still necessary to have a human in the loop, in this case, medical doctors.
Okay.
Thank you very much, sir. Mr. Christian, sir, please, I want to ask, online, how do you source data? I know some people who have worked on, some projects in the time past must have put some data online for anyone who wishes to use them. So how do you feel I can go to download data such as images, audio, or videos that I can use to train my own models, sir. Thank you, sir.
Yes, thank you, Victor, for the question. It's a little bit of doing like a detective work. As easy sometimes, not so easy some other times. In my case, for example, I ended up finding this information through board messages. So people use chatting on boards and referring to GitHub, referring to Kaggle. I do recommend you check Kaggle competitions. So Kaggle. Let me put it here in the chat. So if you go and check it out, that's a really good web page. And what they do is they provide competitions to the open community of machine learning and deep learning researchers. And then they also provide data sets for many different projects. And you can get those data sets for free. That's one way to do it. Also, I would recommend you to go and check out some of the machine learning research groups in different universities. Some of them have data sets that are openly available so that anybody could download them. Go check out MIT, go check out UCI. I'm not sure if, there are many more, but I don't know them all. But it's good to just look around in the universities and look for data sets for machine learning. There are many, many, many available. Also, a different way to do it is to go, and this is the detective part. You can also go to research papers, and in the research papers, the researchers actually tell you where the data set is from. And they will let you know that they took the data set from certain area, certain page, certain company, etc. And that data is openly available, and then you can check it out. So that's a different way to do it. And that's how I did it, by the way.
Okay, sir. Thank you very much, sir. I'm very grateful, sir.
Thank you for your question.
So, Christian, thanks again. I don't know. I have a lot of questions actually, but I don't want to stop the activities of the day. Feel free also.
Have a chat.
Yes, feel free to write to Christian. I'm inviting Christian also if he is free next Friday for the final event where the students will present their project. I don't know if you have time, you're more than welcome to join us. So let me stop this recording.